Spectral repair takes the kind of processing we saw in the dehum and denoise clips and ratchets it up considerably. The spectral-based denoise modules use that technology to learn and remove unwanted steady background sound from an audio file. Spectral repair brings user control to the task of identifying more complex components of a complex audio signal and removing them. This module makes use of the main spectrogram display in RX. I briefly went through the spectrogram display and the various tools in video number 2, so if you're skipping around, you might want to review that clip before proceeding. If you can identify a sound visually in the spectrogram, you should be able to select it with the various selection tools and then remove it. And if you've never worked with a spectrogram display before, you might be pleasantly surprised with just how well you can identify different elements with the visuals provided, even when they're embedded in the dense audio sound field. The Spectral Repair module window has 4 tabs: Attenuate, Replace, Pattern, and Partials plus Noise. Each of these analyzes the selected part of the spectrogram and the surrounding audio and attempts to remove the offending sound using the nearby audio as a guideline. Attenuate is the simplest and fastest approach. It reduces the level of the unwanted audio by modifying it to be more similar to the surrounding wave. Replace interpolates data from the surrounding audio and uses it to completely replace the selected sections. Pattern tries to identify patterns in the surrounding audio and use them to interpolate replacement data. And Partials plus Noise basically does what Replace does, but also takes into account the harmonic structure to interpolate the replacement data. Each of these is more CPU intensive than Attenuate. Aside from those general guidelines, you'll have to use a little trial and error to determine which will work best with a particular audio file. Normally, I'd start with the simplest, Attenuate, and if I don't get the results I'm looking for after a little experimentation, I'd move on to the others, trying each one initially at the default settings, and then tweaking the various controls to fine-tune the results. As you can see, each of the modes has similar controls. Attenuate has a strength slider, which naturally sets the degree of attenuation of the selected material to be removed. Most of the modes have a surrounding region length slider, which determines how much of the audio surrounding your selections will be used for interpolation to fill in the processed area where the offending sound was attenuated or removed. Depending on what the audio is doing, you could tweak this to make sure a suitable amount of surrounding audio is used without catching any unsuitable sound. Before-after weighting weights this process to more heavily depend on the area of the wave either before or after the selected section. Again, you could tweak this to favor the most appropriate portion of the surrounding audio, possibly improving the resulting sound. You can choose the number of frequency bands used in processing. More is not necessarily better. Smaller values are more suitable for removing shorter sounds. There's also an option for multi-resolution. I found that this often provides smoother results, but with all of these controls, it's always going to be dependent on the particular audio signal you're working on, so a fair bit of experimentation will always be needed for the best results. The other critical aspect of the process is to be sure to make a good selection or selections. Try to identify the areas that correspond to the offending part of the sound as carefully as possible, and then try to limit your selection to just those areas as closely as you can. I usually prefer the lasso tool, but whatever gets the job done. Let's look at a couple of examples. I'll pick up there in the next clip.